Corporate finance practice problem using Excel. Expected value for multiple years and NPV, net present value. Get ready, it's time to take your chance with corporate finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, note that we're on the practice tab as opposed to the example tab. The example tab in essence being an answer key. We have the information on the left-hand side. We're going to populate that into the blue area on the right-hand side. We're going to apply our statistical type of analysis once again to try to make better projections into the future. This time we have a capital budgeting type of scenario, those types of scenarios in which you have the future outflow going out up front, and then you're going to be receiving money back in the future. And of course, that's going to be a projection. How much are we going to get back in the future? Now, we could use our statistical type of analysis to try to think about each year that's going to happen into the future. So for example, we might say we're going to have that initial investment going out. We're going to say of the 1,400, cost of capital discount rate is going to be the 15%. And then we might say, well, in year one, let's predict how much we're going to get back and possibly use our scenario here to do so. Say if it was low, average, or high on a year-by-year basis. So let's imagine in year one, we're going to say, well, if it was low, we're going to imagine we get the 300 back. If it was average, 400, and high at the 1,000, and then try to weight that out. So that's another way that we could basically try to break down a capital budgeting project on a year-to-year type of basis to think what the cash flows would be as the cash flows come in on a year-to-year type of basis. And then we'll have to apply our percentages, this being 40, 20, 40. We're going to make it a little bit more confusing as well, just to show some variation here. Note that we could then say, well, if the capital project had year two revenues, do the same thing for year two and year three. We're going to imagine here that we're only getting revenue back periodically for this type of capital project that's going into play here. So the next year that we're going to get back, we're saying is year three. So we had revenue coming back in year one, no revenue in year two, and then we're going to have the dispersed revenue in year three, where we're going to apply the same type of analysis. So in year three, we're going to imagine low, average, or high returns that on these numbers, the non-discounted numbers, right? We're going to average or assume what we're going to get here, and then we'll apply our percentages for this year of the receipt. And then we'll do the same for the next year. We're going to imagine we're not going to get any more money until year 9. So then year 9, we've got cash flows from the same initial investment, and we're going to apply our analysis of the 400, the 8, and the 9, and the rates at the 40, 20, 40. So then once we do that, we can then try to use our present value type of analysis here to then present value our expected returns, the expected returns not for the full project now, but on a year-by-year type of basis. So let's see what this would look like. So we're going to say this is going to be for the first year. We're putting 1,400 down. For the first year, we're going to assume these three options that we might get, and we have the rates at the 40, 20, 40. So we're going to say 300 times the 40%. We've got the 800 times the 20%, and then the 1,000 times the 40%. Adding those up, summing up, we get the expected value. Obviously, the total percentages have to add up to 100%. Note that the names low, average, high are not really necessary here, but they might help you to just get an idea of what the numbers are meaning. Obviously, low on the cash flow inflow, the lower number is not as good, and then higher is gooder, better, and so on. And then we'll do the same for the second one. So the second one, this is year 3. So we're imagining dispersed inflows from the same capital budget outflow. It could be year to year. You could do the same thing on a year-by-year basis, imagining the cash flows would be different from each year, and try to do that, figure that out. But we're going to say this is going to be the 500 times the 30%. This is going to be the 800 times the 40%. This is going to be the 1,002 times the 30%, summing up the percents. They, of course, need to add up to 100, summing up the amounts for the expected value. Then they add up to an expected value of 830 for this year. And then we have year 9, same kind of scenario. We got these three estimates that we're going to make, and then the percentages that we're going to be thinking happens out in year 9. So 400 times the 40%, 800 times the 20%, 900 times the 40%. Underlining that font group, underline, let's sum these up, equals the SUM. And picking those up and summing up for the expected value, this time being the 680. So now that we have these expected values from the inflows, then we can present value them. So we've now looked at the future inflows on a yearly basis. Then we can apply our net present value to those yearly amounts. So I'll do the other calculation on this to get our coefficient of variation as well, just to round out our calculations here. And then we'll do our net present value calculation with the numbers that we had received. So let's take a look at these. We're going to say we have this equals the 300, the 800, and the 100. The expected value or average value is going to be then the 680. Going to bring that all the way down, 680. We'll subtract this out. This is going to be the 300 minus the 680. Going to copy that down, put our cursor on that, use the fill handle to copy it on down. Squaring it now, this is going to be equal this number squared shift 6 caret number 2 for squaring it. I'm doing this more rapidly, note, because we have seen these in prior problems. You can go back to the prior problems if you want to spend more time on these calculations. It's just good practice to do them multiple times. I'm going to then copy that down, square rooting all of them, and then apply out our probabilities, which is a 40, 20, 40 this time. Going to select these three cells and make them a percent number group, percentifying them. Copying the 40, Control C, down arrow, holding down Shift, down again, Control V to paste. And then we'll multiply this out. The 144.4 times the 40%, the 14.4 times the 20%, the 1024 times the 40%, underline, font group, and underline. Summing it up equals the SUM, Shift 9, up arrow, holding down Shift, up, and Enter. We got the 1016. That's going to be our variance. So we got the variance. Let's do the standard deviation, which is the square root of that number. So we're going to say this is going to be equal to this, or not like that. That's not how you do it. That's not how it works. SQRT, square root formula, function, whatever that is, square root of that number. And then let's add some decimals. Numbers, couple decimals there. And then we have the expected value that we calculated, which was that average. The average we did over here, the 680, underlining that. And go into the font group and underline. That's going to give us our coefficient of variation. Dividing this out, this is going to be equal to this divided by this. And then I'm going to add some decimals there. So there we have that. Let's do it for the second one, just to practice this out, practice this coefficient calculation. This equals the 500, copy that, Control C, down, Control, holding down Shift, and Control V. Expected value is going to be the 830. This is going to be equal to the cell above it. I'm going to copy that, Control C, down arrow, Control V. The difference is the 500 minus the 830. I'm going to copy that, Control C, down arrow, holding Shift, down again, Control V. Going to square it. This equals the negative 330, Shift 6, caret, in other words, 2 to the power of 2. Copying that, Control C, down arrow, holding down Shift, down arrow again, Control V. Probabilities, that's going to be our 30%. I'm going to select these three cells, make them percents by going to the number group, percentizing them. Copy the 30, Control C, down arrow, holding Shift, down, Control V. Multiplying 1089 times the 30%. Copying that cell, Control C, down arrow, holding Shift, down arrow, Control V. Let's put an underline here by going to the font group and underline, and then sum it up with the SUM. Sum it up with the SUM, and that's going to be then the variance. Standard deviation. Standard deviation is going to then be equal to the SQ square root, SQRT, Shift 9, up arrow, Enter. Adding some decimals, number group, couple decimals. Then we'll take the expected value, which I'm just going to say is equal to this name up there. Expected value is the 830. Underline on that one. Let's underline it. Put the line underneath, known as the underline. The line underneath is known as the underline. And then we'll divide this out. The 272.21 divided by the 830. Adding some decimals. Number, couple decimals. Let's do that one more time, and then we'll get to the new thing here. So we'll just practice this one more time. Last one, the 400. Copy that. copy that, Roger out, copy that, Roger. And then we're going to say the expected value is the 680. Going to say this this equals the 680. Copy that, paste it here. So there we have that. And then the difference, the 400 minus the 680. Copy that, Control C, holding Shift down, Control V. Squaring it equals the negative 280. Shift 6 to 2, the power of 2. Copy that, Control C, down arrow, holding Shift down again, Control V. Probabilities, let's select these three cells, make them a percent, number group percentifying them. This is going to be the 40, 20, 40. This is the 40. Copy that, Control C, down, Shift, down again, Control V. Multiplying out the 78.4 times the 40%. Copy that, Control C, down arrow, holding Shift, down, down, Control V. Underline the line underneath, known as the underline, and then equals SUM, the sum, Shift 9, and there we have that. That's the coefficient of variation again. So we've done that a few times now. It's probably nauseating, but that's good. It's a good nauseation. This is going to be this SQRT, Shift 9, square root, number group, adding a couple decimals, expected value then, the value that we expect. This is what we expect. Let me lay down my expectations here. Expectation, 680. That's what's expected of you. Investment. And then we've got the coefficient of variation, which is going to be equal to the standard deviation divided by the expected value. And then we'll add some decimals. So there we have that. Okay, so now let's finally do the net present value, which is kind of like the new thing that we want to go to here. So we're going to do the net present value. It's a little bit tricky because we have year 0, year 1, and then we skipped up to year 3 and then year 5. I want to make sure I put the years in here so that we could use these as a cell reference. I'm going to center this, and then we just pick up our numbers. I'm going to say the year 1 was the initial investment that went out. We're imagining of the 1,400, and I'm sorry, year 0, and then in year 1 is our expected value of the 680. And then year 2, we had no return. Year 3, we're going to imagine the return is 830, and then we skipped up to year 5, no return in year 4. It's actually not year 5, it's year 9. It should be 680. This should be a 9, year 9. So there we have it. And then if we have those properly allocated, we can use our present value calculation, picking up these numbers to the left. So in other words, negative present value, Shift 9, rate is going to be equal to this 15%. I'm going to do this faster because we've seen these in the past. F4 on the keyboard so I can copy it down, comma, number of periods is 0 this time, which means we're going to get the same result, but it'll allow us to copy it down, comma, comma. Future value is going to be that 1,004 and enter, same number because at period 0. Then I'm going to copy that and then paste the formula down and double click to see if it's doing what we think it should. It is. Is it picking up the right rate? Let's use our little pointer thing over here to see if it's going to the right rate. You could find those, by the way, in it's the review area. The review area? No, it's the formulas area. These things have your pointer to show you what's going in that formula. There it is. That 15's included in there somewhere. So I think that's good. I'm going to remove my pointer line and sum this up equals the SUM. Summing that up. Underline here, font group, and underline. This is going to be the total, or the net present value. Now note that this skipping around on the years might bother you. So let's build this table just having our normal kind of years here, just to see what that would look like. If I went 0, 1, and then we brought this up to 9 years to get a better idea. And this might give a good idea if we were to present a project like this, which was a little bit weird in its nature, so that we can present a better understanding of what's happening from year to year, right? We'd say, well, the initial investment went out, which was the 1,004. We're going to get a return after the first year of the 680, and then 0 return in year 2, and then year 3 we're going to get a return of the 830, 0 return 4, 5, 6, 7, 8, and then in year 9 we're going to get a return of, not a negative return, a return of 830. And that's an unusual structure. So we're just adding an unusual kind of return structure here, but that's what we're looking at. So now we're going to say then the present value of that negative present value, same calculation, shift 9 rate is going to be that 15%. And then let's say F4 on the keyboard, comma, number of periods 0, comma, future value, same number here. I'm going to then copy that down. And so there we have it. Now this last one, year 9 is wrong. Year 9 should be this 680. There we have it. So that's right. And then we can sum this up. This equals the sum. And so then we get to the same result. And now you can see each of the years, and that might be a better pictorial way to think about it if you were to display it to someone. Obviously, it's a little bit more work possibly to do. Let's make it nice and pretty. Make it blue. Everybody likes the light blue. And then we'll put some brackets around it. That looks excellent. Let's put an underline here under the line. So just note this is another way that you could basically use this kind of analysis. On this capital budgeting long-term decision-making process, we had the uneven payments, and then we're thinking we can use this process to analyze what we believe the inflows would be on a year-to-year basis, possibly giving us a better or more accurate thought process in terms of the actual inflows that are going to happen on a year-to-year basis, and then use our net present value once we have the expected values on a year-to-year type of basis.